My dear students, good morning. I am Ramesh, chemistry faculty from Sri Vidya Mandir Metric Higher Secondary School, Uttangarai. Let us start 11th Standard Chemistry, Unit 12, Basic Concepts of Organic Reactions. Basic Concepts of Organic Reaction. What do you mean by reaction? We may take reaction. What do you mean by reaction? In any reaction, the reactant, what is that? The reactant is converted into product. Reactant is converted into product in one step or one or more steps. Now, we may take the reactant. In a reactant, what happened actually? The older bonds are broken. Older bonds are broken and new bonds are formed. New bonds are formed. So, in a reaction, older bonds are broken and new bonds are formed. Then it is converted into product. Now, how will you represent the organic reactions? So, if you are taking the organic reaction, then we may take substrate. What is that? Substrate is reacted with the reagent. Then it will be gives intermediate. What is that? Intermediate are called as, that is, transition state. Transition state. Then it is converted into product. It is converted into product. Now listen. Here the substrate, it is an organic chemistry, so that the substrate should be an organic molecule. Substrate should be an organic molecule. Now, the reagent, which is considered as attacking species. Now, it may be organic or inorganic, or sometimes maybe heat or photon. So, the reagent may be organic or inorganic or sometimes heat or photon. Now, we may take the intermediate. There are so many intermediates are there. And some of them we may say here, it may be radical. It is called as free radical, or maybe carbocation, or maybe carb anion, or maybe benzene. What is that? Benzene, not benzene. And or maybe carbene. So these are all reactive intermediate. Among these, in this lesson, we are seeing free radical, carbocation and carbanion. Then it is converted into product. It is converted into product. Benzene. So, most of organic reaction occurs a single step or more than one step. More than one step. So, most of the reaction occurs a single step. That is, directly reactant is converted into product. In some cases, the reactant is converted into another one product, and it is not a product, it is intermediate, and intermediate is converted into product. Now, we are taking that reaction mechanism. And what actually reaction mechanism describes? The reaction mechanism describes what is the actual change of the reactant in each step. So, reaction mechanism describes the chemical change of the reactant in each step. Chemical change of the reaction in each step. Suppose we may take reactant. It is a reactant. Reactant is converted into A. A is converted into B. And B is converted into product. So it is a multiple step. Now the first step may be fast. And the second step may be fast. And the third step, it is the slowest one. If it is the speed or rate of the reaction is dependent the slowest step of the reaction. So it is called as RDS. That is rate determining step. So rate or speed of the reaction is depends the slowest step which is called as rate determining step, RDS step. So rate or speed of the reaction depends upon the slowest step of the reaction. Now, in each case what will happen? The reactant cross the energy barrier and converted into another one, A. Now, A is also converted into B and by crossing some energy barrier. And B is converted into product. So, each and every step, the reactant molecule passes the energy barrier and converted into the product. Now, these are all, that is intermediate. A and B are considered as intermediate. Okay, and now we may take that is fission of a covalent bond. Fission of covalent bond. And here it is an organic chemistry. So organic molecule is made up of covalent bond. What do you mean by covalent bond? That is a sharing of electron. So all organic molecule made up of covalent bond. Covalent bond. And covalent bond is nothing but sharing of electrons of atom. Now, this covalent bond breaks into two ways. So, the covalent bond breaks up into two ways. One is homolytic cleavage. Homolytic cleavage. Homolytic cleavage. It is considered as symmetrical cleavage. It is considered as a symmetrical cleavage. Symmetrical splitting. Then another one, heterolytic cleavage. Heterolytic cleavage. And heterolytic cleavage is considered as unsymmetrical cleavage. What is that? It is unsymmetrical cleavage. Unsymmetrical cleavage or unsymmetrical splitting. So, the organic molecule may be splitted into two ways. One is homolytic cleavage and heterolytic cleavage. Now, homolytic cleavage. Homolytic cleavage. take a homolytic cleavage in organic molecule. Suppose we are taken an organic molecule, A is bonded with A. And you know that here a bond is made up of 2 electrons. Here it is made up of 2 electrons. Now, in a homolytic cleavage, what happened? The bonded atom retain 1 electron with each. So, the bonded atom retain 1 electron each. So, a bond is made up of 2 electrons. By sharing of these 2 electrons and make a covalent bond, in homolytic cleavage, what happened? The bonded atom retain 1 electron. Now it is represented by half-headed arrow mark. Half-headed arrow mark. So we may take it leads to A with 1 electron and another one A with 1 electron. They are called as free radical. They are called as free radical. So, homolytic cleavage leads to free radical. Homolytic cleavage leads to free radical. Now, what are the characteristics of free radical? These free radicals are high reactive species. It is highly reactive and it is highly unstable. It is highly unstable. Then it is a short-lived. It is a short-lived species. Then they are all neutral species. They are all considered as a neutral species. Now, it is 1 electron, so it may add 1 electron to attain the stability. So, it may add another 1 electron to attain stability. So, these are all the characteristics of free radical. So, homolytic cleavage leads to free radical. What is it, homolytic cleavage? Here, the bonded atom retain 1 electron each. Now, what is the condition when the homolytic cleavage will happen? So, the condition of homolytic cleavage. The first condition is non-polar covalent bond. Non-polar covalent bond. So it will be occur only in non-polar covalent bond. What do you mean by non-polar covalent bond? That is, similar electronegative atom is bonded with each other. Similar electronegative atom bonded. So a non-polar covalent bond is formed by similar electronegative atom is bonded. So the first condition for homolytic cleavage, non-polar covalent bond. Then the second condition, it may occur at high temperature. High temperature. So at least more than 500 degrees Celsius. And the third condition, in presence of UV light. Presence of UV light. So, these are the conditions the homolytic cleavage is occur. Now, some of the chemical compound which promotes this homolytic cleavage are called as initiators. So, that is cleavage initiators. So, some initiators are there. So, we are taken the first example AIBN. AIBN may act as the initiator which promotes the homolytic cleavage. What is AIBN? Is nothing but it is isobis. A for isobis. Then isobutyronitrile. Butyronitrile is AIBN. Isobis isobutyronitrile. The structure is, you know that azo, N double bond N is considered as azo. Now it is bonded with isobutyro. So here carbon and CH3 and here CH3 and here C triple bond N. It is Cn. It is isobutyro. So isobutyro is bis isobutyro. Bis means 2. So another one molecule C and CH3 and C triple bond N and that CH3. So this is bis isobutyronitrile may promote the homolytic cleavage. Another one example, the second example, it is benzoyl peroxide. Benzoyl peroxide. So, you know that benzoyl. What is that benzoyl? That is C6H5. It is C6H5, C double bond O, which is called as benzoyl. C6H5 alone is phenyl. It is C6H5CO is benzoyl. And it is peroxide. O bond O. It is peroxide bond and another C double bond O and C6H5. Then it is benzoyl peroxide. This benzoyl peroxide may act as the homolytic cleavage promoter or act as a initiators. Then in presence, this benzoyl peroxide is converted into, that is C6H5, and here the phenyl free radical and 2 moles of CO2. So this produces the phenyl free radical. So homolytic cleavage produces the free radical, and the free radical is occur only certain condition, and some substances promote the free radical cleavage. Example AIBN and benzoyl peroxide. Now the stability order of free radical, and free radical stability and carbocation stability both are same. Now here we may take that is tertiary butyl. So tertiary CH3 thrice C free radical. So it is a tertiary alkyl free radical and it has greater stability than secondary CH3 twice CH. Then it is a secondary and primary CH3 CH2 free radical. It is a primary and methyl free radical and vinyl free radical CH2 double bond CH free radical and phenyl free radical. These are all the stability order of free radical. Stability order of free radical, it follows tertiary, secondary, primary, methyl and vinyl and phenyl. Now we may take the next one, heterolytic cleavage. Heterolytic cleavage. Heterolytic cleavage. Listen, if you are taken A is bonded with B. A is bonded with B. Now we may take it is a bond. A bond is made up of 2 electrons. In heterolytic cleavage, what happens? The bonded atom retain a pair of electron with 1 atom. So bonded atom retain pair of electron itself. Pair of electron itself. And among these, which one has most electronegative? Then the bond pair of electron will move towards the most electronegative. Suppose here we may compare the electronegative of A and B. A has more electronegative than B. What will happen? If A is more electronegative than B, then the bond pair of electron will move towards A and it will be represented as a double-headed arrow mark. If it is a free radical, it is represented as single-headed. Now it is a double-headed because here A is highest electronegative than that of B. So it will be leads to A minus and B plus. And A minus is nothing but anion. And B plus is nothing but cation. So which one has highest electronegative? Then it will be form an anion. And lowest electronegative atom form that a cation. Here. So heterolytic cleavage leads to carbocation and carbanion. Maybe a cation and carbanion. If it is an organic compound, when carbon is attached with high electronegative atom. For example, here the carbon is attached with a high electronegative atom, that is bromine. So we may take here it is CH3 and here CH3 and CH3. So carbon is bonded with a high electronegative atom. Then what will happen? Now compare the bond carbon and Br. So we may take the electronegativity Br has greater electronegativity than that of carbon. So when carbon is attached with a high electronegative atom, the bond pair of electron will move towards the highest electronegative atom. Then what will happen? Here we may take that is CH3 and C and CH3 and CH3. Now we are getting a negative, then it is anion. Now carbon getting positive charge because it loses its own electron, so that it is a cation. When carbon has a positive charge, then it is called as carbocation. Carbocation or otherwise is known as carbonium ion. Carbonium ion. So how will you produce a carbonium ion? When carbon is bonded with the highest electronegative atom, it may lead to carbonium ion or carbocation, and it is a reactive intermediate. It is a reactive intermediate. Free radical is one of the intermediate and carbocation is also one of the intermediate. Now, what is the stability order of these intermediate carbocation intermediate? So, we may take the stability order. Stability order of carbocation. Stability order of carbocation. Listen. Here we may take this one cyclotriphenyl methane. Tricyclopropyl methane. So tricyclopropyl methane is the highest stability. Then it is dicyclopropyl methane. We may take here that is a CH plus and we are taking cyclopropyl. So it is tricyclopropyl methane. methane carbocation. Now it is dicyclopropyl methane. Dicyclopropyl methane. Dicyclopropyl methane. And after that, it is cyclopropyl. We have taken it is a CH2 plus. Cyclopropyl. Then after that, it is tropylium ion. We are taking a tropylium ion, and here the one, here the one. So it is a tropylium ion. So tricyclopropyl methane, dicyclopropyl methane, and cyclopropyl methane and tropylium ion. And the next one we may take, it is triphenyl methane. That is CH, and here C and pH and the pH. So it is triphenyl methane, and it is equivalent to, that is R, C and that R, and bond CH, double bond CH2, it is positive. Then it is tertiary allyl. Tertiary allyl. And after that, it is diphenyl methane, CH plus and pH. Then it is diphenyl methane, and it is equivalent to secondary allyl, that is R, CH plus and CH double bond CH2. It is secondary allyl. Secondary allyl. And the next, after allyl group, it is benzyl. You take pH and CH2 plus. It is benzyl. So it is a benzyl, and after that it is allyl. That is CH2 plus and CH double bond CH2. And after that it is tertiary CH3 thrice C plus. It is tertiary, and secondary CH3 twice CH, and primary CH3 CH2 plus and methyl group CH3 plus and vinyl group CH2 double bond CH plus and phenyl group. We are take pH plus. So it is the order of that carbocation. So carbocation stability, we are take tricyclopropyl methane, dicyclopropyl, cyclopropyl methane and that tropylium ion, and triphenyl methane, and it is equivalent to tertiary allyl group, and diphenyl methane, and it is equivalent to secondary allyl. And after that benzylic, allylic, tertiary, secondary, primary and methyl, and that vinyl and phenyl. These are the stability of carbocation. And in your book they are taking only this tertiary, secondary, primary and methyl group. But for need concern it requires. Now in the case of heterolytic cleavage, when the electronegativity of carbon is greater than other element, then what will happen? So the electronegativity of carbon will be greater. So carbon getting a negative charge, then it will become carbanion. Carbanion. So for example, we may take that here, that is hydrogen and CH2 and CHO in the case of aldehyde and ketone. Now here carbon is attached with the hydrogen. Then what is the electronegativity? Here the electronegativity of carbon is greater than hydrogen, so that the bond is polar. The CH bond is polar. Now what will happen here? The bond pair of electron will move towards the carbon and carbon getting a negative charge. So what will happen here in presence of OH minus? So aldehyde in presence of OH minus is nothing but aldol. We are getting that aldol condensation. In the case of aldol condensation mechanism, we may produce a carb anion. So here that is CH2 minus bond CHO and removal of H plus. So carbon getting a negative charge, then we are called as carb anion. So carb anion. Now we may produce a carb anion when carbon has highest electronegative than any other atom. When carbon has lowest electronegative than other atom, then we may produce a carbocation. And similar way here the carb anion has a stability. So we may take the stability order of carb anion. Stability order of carb anion. Now we may take the stability. We are taking that diphenyl methane, that is CH minus and pH. It is diphenyl methane carb anion has greater stability than that of triphenyl methane carb anion. Here pH and here pH. So diphenyl methane carb anion has greater stability than that of triphenyl methane carb anion. And after that, here it is benzyl, that is benzylic carbanion and allylic carbanion, that is CH2 minus and CH double bond CH2. So benzylic and allylic are common in all cases. And after that it has methyl carbanion and primary carbanion CH3 CH2 minus, it is a primary carbanion, and after that secondary carbanion CH3 twice CH minus, a secondary carbanion, and after that tertiary carbanion CH3 and thrice C minus, and vinyl carbanion CH minus CH2 and phenyl carbanion. So, in the case of stability order, carbocation and carbon free radical both are almost the same. But in the case of carb anion, primary, secondary, tertiary is the order. If carbocation, tertiary, secondary, primary and methyl group. If carb anion, primary, secondary and tertiary. Primary and secondary and tertiary are most stable. So it is the stability order of carb anion. Students, in this class we may take what is that reaction and what is that reaction mechanism and what are intermediate. The intermediates are free radical and carbocation and carb anion. Then how it will be formed from that reaction. Carbanion, how will be formed? When carbon has highest electronegative than other atom. Then carbon has lowest electronegative, then we may produce as carbocation. Free radical, homolytic cleavage leads to free radical, and we may see the stability order. Okay, and after watching the video, go through your textbook and NCERT book. Thank you.